1, it says simplify, leave answers in radical form. All right. So there are two ways of doing this. The way I showed you was the faster way. There is a longer way to do it. It just depends on how big this problem is, okay, this number is. So we're starting with 300. I mean, a number like 300, students, you should recognize that 300 is divisible by 100. I mean, that should be obvious. If that's not obvious to you, then we need to have a conversation, okay? So 300 is divisible by 100. So I can split this up into the square root of 100 times the square root of 3. I always write my perfect square first because it just flows into the problem much better if you put the perfect square first. Okay, it's not wrong if you don't. Any questions about what I've done so far? Remember, when you split it up, one of the factors, at least one of the factors, has to be a perfect square. And when I say perfect square, I mean 1, 4, 9, 16, 25, etc. It's best if it's the largest, but if it's not the largest square factor, then when you're finished, always check and make sure, can I break this number down one more time? All right. So if you had used 25 and 6, well, 25 and 6 or whatever the number is, it will still multiply out correctly. Okay. However, it can still be broken down sometimes. So you have to do, I don't know, what number times 25 is 300? Somebody, 300 divided by 25. Is it 8? 12. Okay. So if you were to, I see you, darling. If you were to use 12, don't talk now, okay? If you were to use 12 and 25, 12 and 25 does make 300. The problem is 12 breaks down again. And so if you stopped with 5 times the square root of 12, it would be wrong because 12 can break down. So that's why it's important that you either recognize that you have to keep breaking it down or use the largest square factor to start with, and then you're good, okay? So that's why I gave you that strategy of cut the number in half and then find that number on your list and work up the list until you find the largest square factor, okay? What did you want to ask, my dear? Because 100, the square root of 100 times the square root of 3 equals the square root of 300. I haven't taken the square root yet. So now the next part will be 10 square roots of 3. Okay? So when you're breaking a radical up, remember, you're breaking it up into two radicals that multiply to give you the original radical, okay? All right, is that good? Any questions about that? I'm happy. I know I've been fussing, okay? You guys don't see that side of me every day, but I was a little frustrated. I want you guys to do better. I know you guys can do better, okay? So please, I want to help you. Don't feel like you can't ask me questions. I want to answer any question you have, okay? Are we good? Okay, let's keep moving. So number 2, now when you have this situation, then you want to multiply those back together first and then split it back up. The reason we have to do that is neither of those factors are square factors. So you can't work with that. So when we multiply those together, I believe that was 147. And then once you do that, you want to break that up, and it turns out that 147 has a perfect square factor of 49. So, like Jordan, remember how you were asking me? So when I break this up, I'm going to write it as the square root of 49. So I still have to have that square root in there times the square root of 3. Now, yes. Because 7 times. Okay, what is that right there? What's that dot right there? Yeah, so try that. Okay, yes. I don't know, when you can't break 7 and 21 down. Neither of them have factors that are perfect squares. So you can't use 7 and 21. You have to multiply it together and then break it down differently. Yes, I see your hand. 147 has a perfect square root of 49.
49 times 49 is not 147.
Okay, is your question? All right. Okay, let's get this going again. So anyway, then the square root of 49, that's a perfect square. So I can write this in simplest, now that's a 3. So now that's in simplest radical form. Let me fix that. CJ, everything with your question?
No, I just want to take a look at it.
Are you talking about my handwriting?
Yeah.
Okay, question.
I think my phone.
Okay, different way depends, because I don't know a different way to do this, but I'll look at yours individually, because some of you guys did have some creative ways, but they were not mathematically sound. So I have to be able to follow your work. So there's really no other way that I know of to do this, but I will look at yours individually to see what happens, okay? All right, sir. Okay. So I saw a lot of unique ways, and you finagled it, you finessed it, but mathematically it wasn't correct. Okay, it looked good. Okay, I could see what you were doing, but it wasn't. You didn't follow the rules of mathematics to do it. Okay. All right. So let's take a look at this problem. There are a couple of approaches to this problem. The most direct one would be to rationalize the denominator at this point. And so, now, this radical 3 times radical 15, yes, ma'am. Okay, is 7 times 21, isn't that 147? Just make sure my math is right. Well, okay, so picking back up where we were, so now just like the radical 7 times the radical 21 over here was equal to radical 147 because we multiplied them. So what am I going to do going across the top here? Well, yeah, so what's 3 times 15? 45. And then what's the square root of 15 times the square root of 15? It's going to be 15, okay? Because it's really the square root of 225, which is 15, okay? Now, that is not in the simplest radical form. Because of what? How do I know? Right, because 45 contains a square factor of what? What is it? 9. Okay, a number from our square factors list. We're talking about our 1, 4, 9, 16, 25, etc. Okay, from that list. So 45 is divisible by 9 evenly, right? Can you see, okay? All right. So I have to break this down into the square root of 9 times the square root of what? 5 over 15. Now, what's the square root of 9? 3. Square roots of 5 over 15. But what else can I do? I can simplify one more time than just the numbers. 3 over 15 reduces to 1 over 5, right? That 3 divides into the 15 5 times. So your final answer is simply radical 5 over 5. Okay. Alright, so let's keep it moving. So there was another question. CJ, you had a question?
Yeah, so I can get to 45 minutes.
I had to start over again. I had to start over again because 45 could break down. So I had to, so 45, so I broke it down into radical 9 times radical 5 because 9 times 5 is 45.
So how can you get 55?
Okay, wait, let me do one, let me finish with him, and then you're next, and then Kenyon, okay? Alright, so CJ, so I broke 45 up into radical 9 times radical 5, and then over 15, okay? So I'm just going to back it up. Right, but it's not in simplest radical form. So then what is the square root of 9? 3. Square root of 5 over 15. Okay, Tiffany, question? I'm sorry, Fatima, I called her Tiffany. This part right here? Well, that's just the rule. You have to rationalize the denominator, and that's the rule. No, it has to be the same thing that's on the bottom. Okay, Kenyon? How did we get, you're asking how I got this 15? Is that what you're asking? Square root of 15. So the square root of 15 times the square root of 15 is the square root of 225. That's always going to be a perfect square when you do that. That equals 15. So our shortcut is, oh,
I used to get 5.
oh, from this point, 3 divided by 3, and 15 divided by 3. Common factor. Which leaves us with radical 5 over 5. Just like simplifying a fraction. Okay? Alright, good. So, let's go ahead and look at number 4. So I'm out of space, so I'm going to do number 4 over here. I hear a little chatter. So this is going to be 7 times the square root of 27 times 4 times the square root of 3. So this is a type of problem where you want to regroup. So I say a lot of things. I hope you guys write those things down. So for this one, what would I say? Okay. Yeah, and I would say numbers with numbers and radicals with radicals, right? So we're regrouping. So exactly. So just like you guys said, it would be 7 times 4 times radical 27 times radical 3. All right. So numbers with numbers, radicals with radicals. So what's 7 times 4? 28. And what's 27 times 3? 81. And what's nice about the square root of 81? It's a perfect square. It's a perfect square, which and the square root of 81 is 9. So 28 times 9 is 252. Okay? Hey. Okay. Okay, so are we good? Everybody's good? Everyone's comfortable?
Yes, ma'am.
The answer is 252, right? Oh. Five. Okay, on number 5, it says, excuse me, guys, we can't afford to talk now, come on. Determine the perimeter of the triangle, round to the nearest tenth. So perimeter, how do we find perimeter? Add all the sides together, okay? You should put your phone away. So can I add all the sides together yet? No, why? I'm missing a side. So how am I going to find that side? Pythagorean theorem. A squared plus b squared equals c squared. Leg squared plus leg squared equals hypotenuse squared. Now, the most common mistake I saw, excuse me, I'm competing with some of you. Oops. The most common mistake I saw was that people put the hypotenuse on the wrong side. Okay, so people did 5.7 squared plus 11.5 squared equals c squared. Okay, remember, this is the hypotenuse. Okay, so when you do this, we're going to get 32.49 plus b squared equals 132.25. And we subtract 32.49 from both sides. We get b squared. I keep hearing chatter. Alright. Let's continue. Sorry for the interruptions. So now we take the square root of both sides. So therefore b will equal 9.98. The instructions said to round to the nearest tenth. Well, when you round this to the nearest tenth, you get 10. Okay? It's been a b squared since the beginning of the problem. Okay? All right. Okay? I hear some questions. Okay, 1, 2, 3. You have a question? Kenyon, question. Okay, did you use the calculator and take the square roots? It's the square root. Think about it, because 99 is close to 100, right? The square root of 100 is 10. So doesn't it make sense that the square root of 99.76 is going to be something close to 10? All right? So, all right. What'd you say? Mercy, you have a headphone here? Okay. You press the second key, and then press the x squared key, and it gives you a square root, correct? Okay, so this is 10. So you're going to go 10 plus 5.7 plus 11.5. It asks for the final answer rounded to the nearest tenth, so that's one decimal place. I got 27.2. Okay? But it said round to the nearest tenth, so 0.19 goes up to 2. Okay. All right. Ma'am? 10.5 is too big. All right. So let's look at number 6. Okay, so what do we know about these? What do these numbers represent? Angles or sides? They represent sides. What do we know about the sides of any right triangle? The sides. We know that a squared plus b squared equals c squared. Okay? So what you're going to do is you just want to test to see if which set of numbers fulfill this Pythagorean theorem right here. You mean the ones with the radical? Okay. So let's start off with b. So you fill in the formula. So that's going to be 2 squared plus the square root of 7. Isn't that square root 7? Isn't that the one you want me to do? Squared. And we want to know, does that equal the square root of 11 squared? Now, first of all, we know this is 4. When you're squaring something, remember, that means the square root of 7 times the square root of 7. Well, we know the shortcut for that. The square root of 7 times the square root of 7 is just 7, right? But if you type that into the calculator, it would have given you 7 as well. Okay? So, yes. Okay, is this true or false?
That's true.
That's true. We're looking for which one does not form a right triangle. All of them work except for C.
You mean D.
I mean D, sorry. Okay? Alright. So, I'll just go ahead and erase this so I can put D down. It's very noisy, considering how important this is, what we're doing. And you end up with 1681 does not equal 2025. Okay? So that's why that's what, yes, you should say that past. Yes, go ahead. Find the measure of angle A. So, what do we know about the 3 angles of of any triangle? They add up to 180. So that's one approach. There were 2 approaches, okay? So one approach was to use angle plus angle plus angle equals 180. So that would be x plus 34 plus x plus 68 plus what?
90.
Plus 90 equals 180. The most common mistake I found on this problem was people just set these 2 equal to each other. They just said x plus 34 equals x plus 68. Right? So that was not correct. You had to use the triangle sum theorem. So this is a 1x and a 1x combining like terms. 1x plus 1x is 2x. The other mistake I saw was people combine that and call that x squared. You don't get a square unless you're multiplying. Plus, so 34 plus 68 plus 90, what does that equal? 192 equals 180. And then we will subtract, yes, 192. Now, what I did was I did mine a little bit differently, and I think a few of you did that. Does this give you -12? I just dealt with the two angles here, since I knew that, well, this is 90, and these two have to also make 90 to make 180. So I just did the first angle plus the second angle, and I set that equal to 90. And that's perfectly fine. Or you could do all three angles, all right? But you just have to set it equal to 180 because you included that extra angle, okay? So x equals -6. It's -6. So if you didn't get a -6, then that messes up the next part, finding the measure of angle A. Well, angle A is x plus 34, and x is -6. So when I do -6 plus 34, I end up with 28.
Wow.
Okay, I will wait. Alright, let's go ahead to the next page, number 8. So, it says solve for each variable in the special right triangles. Leave your answers in simplified radicals. Okay, this is the real deal. This is the part that a lot of people struggled on, so pay attention. So, the way we handled these was we wrote out our little table, 30, 60, 90. You must memorize the formulas. There's no getting around that. This is x square roots of 3, and 2x. Okay? Alright, so the next thing you have to do is figure out where to put the information that you were given on your picture. So what were we given in the picture? Okay, the side across from the 30-degree angle is 3 square roots of 5. So where does that go in my table? Under the 30, the 60, or the 90? The side opposite the 30-degree angle goes under 30. Okay, I feel like that's kind of logical, right? Okay. Okay, I know. Okay, I was being nice, and I accept it. You got a decimal? Exactly. Okay, all right. That's fine. Did I mark off points? Okay. So then that meant you could. Okay. All right. If you were able to figure out another way to do it and you got it correctly and you showed your work, I went ahead and gave you credit as long as it was mathematically sound. So, guys, if you guys, you really want me to finish this, okay? All right. Yes. Yes. Jordan. Okay. So now, I know what X is. Students, this is the part I need you to hear. And I need you to help me figure out another way to say this. If those of you who understand this, if you can give me some advice, because I'm at a loss. Whatever you write down here in this last row is always equal to what's above it. So that means X equals 3 square roots of 5. That's what X is, 3 times the square root of 5. That means in the rest of the table, every place there's an X, you have to replace the X with 3 square roots of 5. Okay? So that means this becomes 3 square roots of 5 times the square root of 3. Ma'am. Right, you missed that discussion, so just flow with us, okay? So I'm doing it this way. So this is 3 times the square root of 5 times the square root of 3. What can I simplify? Yes, that will give me 3 square roots of 15. Can I break 15 down? No. No? Not into square factor. 15 doesn't have a square factor. You see what? Do you follow? 15 does not have a perfect square factor. We're done. Okay? So now, let's do the next part. Every place I put an X, I'm going to replace X, every place I have an X, the X will be replaced with what again? 3 square roots of 5. What's already here? A 2 times 3 square roots of 5, which is 6 square roots of 5. Okay? So the hypotenuse is your B, that's 6 square roots of 5, and the longer leg is your A, that's 3 square roots of 15. Okay?
So that's all we have to do?
That's all you have to do.
I guess that's enough to die for seconds.
Okay, let's do the next one. You must stop talking, sweeties. All right. So we have a 45, 45, 90 triangle. Both of the acute angles are 45 degrees. What information was I given? Information across from a leg or from the hypotenuse? Okay. And the formula for the hypotenuse on the 45, 45, 90 triangle is x squared roots of 2. You have to memorize that. Remember, you have to come up with a gimmick that helps you to remember it. I told you my gimmick. If my gimmick doesn't work for you, that's cool. Okay, my gimmick is I have 2 x's, so I remember that needs to be a 2, so I won't confuse this 2 with this 3 over here. Okay? Yes. Are you raising your hand? Okay. Just getting a good stretch in. So now, this 22 here, what side of that triangle is it associated with, a leg or the hypotenuse? Go ahead, Zion. Exactly. So where do I put the 22? Under the X, under 45, 45, 90. So I put a 22 here. Okay, here's the thing. Remember, whatever is up here equals what's down here. Okay? So, God bless you. So just like here, x equals 3 square roots of 5, there's no math to do here because the x is by itself, right? So when I do it over here, I have x times the square root of 2 equals 22. Is the x by itself? No, the x is not by itself. I gotta get rid of that square root of 2 because I need it to say x equals. Okay, so sometimes there's extra work to do, like number 9, but sometimes it's like number 8, and there's no more work to do once we fill in the table. Okay, so now what do I have to get rid of?
You have to get rid of the X.
No, not the x. I'm trying to get it by itself, right? So I have to get rid of the square root of 2. Okay, so now when I do that, I'm going to end up having to, let's see, this is going to cancel, but what's the problem with this right-hand side? You're not allowed to have a square root of 2 in your denominator. I have to rationalize it. So I multiply the bottom by the same thing, and then I do that on the top as well. So that's going to give me, I kind of wrote into my table, that's going to give me 22 square roots of 2 over what, students? Over the square root of 4, which is 2. Can I simplify that anymore?
Yes.
Sure can. 11, yeah, just divided by 2. 11 square roots of 2. So that's what my x's are, guys. Both of the x's are the same. So this one is 11 square roots of 2. This one is 11 square roots of 2. Okay? Right? Any questions about that? Any questions? Good? Okay. You good? Okay.
Oh, yeah.
You got it? I love hearing you thinking out loud. Okay? Okay? Wait. Wait, honey. Okay, I haven't done it yet. Okay, well, let's just work it out, okay? All right. Did I take any points off? All right. Well, sometimes you guys do things a little differently, and so I'm like, okay, I can work with that. All right. Determine the side length of an equilateral triangle if the height is 7 centimeters. So remember, this is the original picture you start off with. We know all the sides are the same, and the height is here, that's 7. So just to make life a little easier, I pulled out the half there, okay? Now, if it's an equilateral triangle, remember, all the angles are congruent. So if I do 180 divided by 3, I get 60. So that's why this angle here is 60. Now, some of you did, okay? Okay, you good. Thank you. Thank you for helping each other out, okay? So the problem didn't tell you what form your answer had to be in. Some people chose to do this as a special right triangle. Some people use a trig function to do it, okay? Either way, I'm good. I'm going to do it as a trig function. Ma'am? Are you good? Oh. Why did I? Because there are three angles in a triangle. I haven't done the problem yet. All I was doing was trying to establish what this angle measure was. Does that make sense? So since it's equilateral, all the angles are going to be equally divided into 180. So I did 180 divided by 3. Okay? So that's real important. So now, I'm looking to find out how long the sides are of my original triangle. So really, I just need to find the hypotenuse of this triangle here. Okay? Terrence, you good? Alright. So what I'm going to do, I chose to do a trig function. I think it was a sine function. So if this is my angle, this will be the opposite side. This will be the hypotenuse. So I did the sine of 60 degrees equals 7 over x. And since x was on the bottom, I had to divide. So x is equal to 7 divided by the sine of 60 degrees. And I ended up getting 8.1. Okay. Yes.
So you divide them out. You could have multiplied that anywhere. So how would you set that up? So that's not.
If it was a multiplication problem?
How would you set that up?
Well, if it was, so suppose the x was here and the 7 was there, it would be reversed, right? So the question was, how do you know when to multiply versus dividing?
No, I know how to do it. It's just how you put it in the calculator.
Oh, how do you just, okay, so you would have, say you ended up with 7 times the sine of 60. You type in 7 sine 60.
Okay.
Yeah, you have to put the 60 after the word sine, because 60 is an angle measure. So you're taking the sine of 60 degrees. Ryan? You have a question? Oh, Nico, sorry.
Can you go back up?
I typed in 7,
Divide it by the sine of 60. It's a division problem. 7 divided by the sine of 60.
so I typed 7 divided by
Mm-hmm. Are you sure? Okay, then press the double arrow key. That if you got 14 radical 3 over 3, Kaylin, did you get 14 radical 3 over 3 on the calculator? Right. So sometimes the calculator will, since it's a special right triangle, to give it to you as a radical. So if you got 14 radical 3 over 3, that's the same thing. If you multiply 14 times the square root of 3, and then divide that answer by 3, you'll get 8.1. Okay? Sir? If you had written it as a radical, that would have been fine. Okay? Alright, number 11. On number 11, a lot of people did extra work on number 11. Okay? And so what happened was, when you're finding a ratio, and remember I told you, the final answer can be a fraction or a decimal. This question was not asking you to find the measure of the angle. And so the most common mistake on this problem was people did the inverse cosine function to find x, and you didn't have to do that. So angle x is here, cosine is adjacent over hypotenuse. So the cosine of x equals 8 over 17. All you had to do was do 8 divided by 17, and you would get 0.4706. That's all you had to do. Okay? Okay, well make sure you know how to do it. Okay? No, you didn't. The only thing, no, this is all you type in the calculator. You don't have to use a cosine function because you don't know an angle and you're not looking for an angle. The only time you actually use the cosine, sine, or tangent button is if you're using an angle to find the side, or you need to find an angle measure. Okay? If it's asking you to find a trig ratio, it's just the fraction that you get when you put the numbers over each other. Uh-huh.
So you did the angle measurement.
Did you try it? Okay, try it and see if it
Well,
works.
I have right here.
Did you try it? You're asking me if,
I did go to test.
but did you try it just now? Okay, did it work? Okay, so you can answer your own question. Number 12, solve for x, round to the nearest 10. Okay, guys, we gotta hurry up. So x for this angle right here, x would be the opposite. This is hypotenuse. So this is a sine of 52 equals x over 17. So Jordan, here's an example what you were asking me about. This would be 17 times the sine of 52. And when you do that, you get 13.4. Okay? Hurry up because we're about to run out of time because we have so many interruptions. Alright? Guys, you can watch this on video. I need to finish, okay? Okay? But you still should take notes and pay attention. Alright? Number 13, solve the triangle. That means you have to find all the missing sides. So you could do Pythagorean theorem, or you could use a trig function. So you could do x squared plus 5 squared equals 11.7 squared. Alright, and so if you do that, guys, you're going to end up getting 10.5, 10.6, okay? Alright, so that's BC. And then I did a trig function to find angle A, so the cosine of A. So here's the case where you're going to do the inverse function. Alright, so we're going to do A equals inverse cosine 5 divided by 11.7. And when you do that, angle A is 64.7, which we said we take angles up to whole numbers. And then this one would be 25. So you just subtract. How did I what? Whenever you're looking for an angle measure. Type this in. Do second cosine, and then do 5 divided by 11.7, because I did angle A, and that's adjacent and hypotenuse. And you get 65, and then if you subtract 65 from 90, you get 25. Alright, let's keep moving. Number 15. 14. Find the cosine of theta if the tangent of theta equals 4 over 3. So what I did for this one, okay, so I just picked an angle and I called this theta. So this is theta, this would have to be 4, this would have to be 3, because tangent is opposite over adjacent, right? So then, this was one of those special triangles, but you could do the Pythagorean theorem to find this. Okay? And so then, if I'm going to do the cosine is adjacent over hypotenuse, so that's 3 over 5. But you were given 3 and 4, and you had to label, and if this is my angle, then to get the tangent, this would have to be the opposite, so 4 would have to go here, and 3 would have to go there, because it's opposite over adjacent. Okay, number 15. Which trig ratios are equal to 12 over 37? So this is just another one where you just had to you had to remember the relationship. So like, it's D, okay? So what's the cosine of A? If this is A, cosine is going to be adjacent over hypotenuse, so that's 12 over 13. 37, thank you. And then the other one is the sine of C. the sine of C is gonna be opposite over hypotenuse, it's gonna also be 12 over 37. Alright, so all you had to do was take each case and try it out and see if it gave you the same thing. Alright? Uh-huh. Yeah, 3 squared is 9, 4 squared is 16, 9 plus 16. I just say write it down. I figured you guys would do that. Okay? Alright guys, I see you're talking, but yet I'm not done. If a cow stands 25 feet away, if a cow stands 25 feet away, so the cow is here, away from the building, this is the building, so the 25 has to go here, the building makes a right angle with the ground, it says what is the angle of elevation, so it's inside the triangle, is it going to be up top or down low? That's my angle. Which trig function would that be if I'm looking, what do I know, the building is 14 feet tall. That's tangent. So the tangent of theta, or whatever you wanted to call it, equals 14 over 25. So how do you find an angle measure? How do you do it? Second. So you're going to do second tangent. So theta equals inverse tangent of 14 divided by 25. What do you get? 29.1, right? Okay, so x equals 29 degrees. All right.